Hello students and welcome to Math Weekly number 10. Our focus skill in this lesson will be to solve for an unknown value in a proportional relationship, and we will learn two different ways to use this. So a proportional relationship by definition is a link between two amounts that increase at a constant rate of change called a unit rate. We have looked at this example in the previous two lessons. Ben has a job working at a local farm. He earns $10 per hour, and we've talked about how $10 in 1 hour is the constant of proportionality. But there's a lot of different possibilities for this situation. So for example, it could be $10 in 1 hour, or it could be $80 in 8 hours, or it could be $40 in 4 hours, or any other combination that does what? Reduces to the constant of proportionality. Now, how could we go between these amounts? We know that these three are all proportional because they could reduce to $10 in 1 hour. But $10 8 times makes $80, and $1 8 times makes 8 hours, or 1 hour 8 times makes 8 hours. So to generate a different proportional possibility, we can multiply both parts of the ratio by the same value. That's multiplying by a common multiple. But if you look at these two examples, we know that they're proportional to each other because they both reduce to 10 over 1. But they also have a common factor between them. If I reduce this by 2, 80 divided by 2 is 40, and 8 divided by 2 is 4, I can prove that they're proportional to each other by reducing by a common factor. So what's true about every possibility? It will reduce to 10 to 1. It will reduce to the constant of proportionality, which also means that we can expand it to get a new ratio, or reduce an already existing ratio to get a different ratio. So what's true? They can all be reduced or expanded by a common factor to generate each other. But what else is true? The cross products of two ratios are equal if and only if the ratios are equivalent. And if the ratios are equivalent, then the situation is proportional. So look at this example. This still relates back to Ben. If Ben works 5 hours, he'd get $50, right? If he works 3 hours, he'd get $30. So this says that the cross products must be equal. So if you take 5 times 30, that's 150, right? And 3 times 50 is 150. Since 150 is equal to 150, these two ratios must be equivalent, and therefore this situation about Ben must be proportional. So another way for you to decide if a relationship is proportional is to check the cross products. This fact will also help us to find an unknown value in a moment. So, if we're solving for a proportional value that we don't know, there are two ways that we can find that value. But either way, no matter which way we choose to do, step one is always the same. We have to set up common ratios. Units and descriptions must match either vertically or horizontally. So, for example, if there are 10 blue marbles for every 6 red marbles, how many blue marbles are there if there are 54 red marbles? When we say that we need common ratios, that means that our units, which are blue and red, must match either vertically, meaning up or down, or horizontally, meaning left to right. There are only two ways that we can do this, vertically or horizontally. But within that, vertically or horizontally, we could switch them two different ways. So the most basic way is to choose the layout of the first part. So it says 10 blue for every 6 red. So put 10 blue over 6 red. Now we have to mimic that with the second one. We need the blue on the top so that they match horizontally and the red on the bottom so they match horizontally. So it says how many blue, which means we don't know, so I'm going to put a variable, which means x, if there are 54 red, so 54 red. So we consider this common ratios because it's blue to red and blue to red. Now, this is not the only possibility. This is just one. We could also reverse this. Even though it says 10 blue for every red, we could put 6 red and 10 blue. Is that still true? There's 6 red and 10 blue. But now our other ratio will need to have red on the top and blue on the bottom, because then it will match red to blue, red to blue. How many red were there? 54. How many blue were there? We don't know, so we put x. So these are two possibilities. Both of these are the two examples of how to align vertically. These two sides could also be reversed. You could have this on the left and this on the right. Now, let's talk about organizing horizontally. This seems a little more confusing for me, but if it works for you, that's fine as well. So it says 10 blue for every 6 red. So I'm going to write it like this. 10 blue equals 6 red. Now I just got to make sure I do it the same way for the bottom. Blue equal to red. So it says how many blue? I don't know how many blue, but I know that there's 54 red. So this would be also an equivalent statement. This is organizing it as a common ratio horizontally. And you could also have this reversed. 6 red is equal to 10 blue, and 54 red is equal to, we don't know how many blue. So let's look at a multiple choice example to practice understanding our common ratios. Here's the situation. Carla is testing toothbrushes at a factory to determine if the toothbrushes are made properly. She finds that 8 out of 32 toothbrushes are defective in a particularly bad manufacturing day. Which two proportions below could be used to show how many she would expect to be defective out of 176 toothbrushes? So here are our 4 options. Now, my best strategy is not to look down here, but to try to write my own. So it says she finds 8 bad out of 32. So that's 8 out of 32. And we want to know how many would be defective. So we don't know how many are defective out of 176. So I wrote the totals on the bottom and the defectives on the top. Is this an option for us? Yes, this is option C. It's just backwards. 8 over 32 is equal to x over 176. So this one's good. But we're looking for 2 different ones. So let's write it horizontally this time. 8 are defective out of 32. How many are defective out of 176? Now, we see the 8 and the 32 aligned, like I have, but the bottom's backwards, so this is not our option. Here we also see 8 equal to 32 and x equal to 176, so this is our other option. So both C and D could be used to show and figure out the value of x. Now, let's work on what are the 2 ways. So after common ratios have been set up, the way 1 says use common factors or common multiples to reduce or expand from the known ratio to the unknown ratio. So we're going to do 2 examples. In this one, you can see that the known values are in the denominator. 5 becomes 35. Well, I know that 5 times 7 is 35, so 3 times 7 is 21. So x has a value of 21. In this example, the knowns are also on the bottom. 40 divided by 10 is 4, so 30 divided by 10 is 3. So x has to be 3. Way 1 only works though if you can find the multiple or factor that will convert you between the two. Way 2 is better when you cannot find that. So here's how way 2 works. After common ratios have been set up, use cross products to create an equation, and then solve the equation using inverse operations to find the value of the variable. Here are our two examples. Now, even though I say it's best to use, this strategy works for any example. We could have used it on the last two as well. So, we need to work on our cross products. So we have to do 8 times 4.75. Since we're getting close to our time limit of 15 minutes on this video, we're going to use the calculator. So 8 times 4.75 is equal to 38, sorry. And x times 19 is 19 times x. We don't know that value because we don't know this number. Now remember, if two ratios are equal, then their cross products are equal. So I have 19 times what number is equal to 38? Well, if I divide by 19 divided 19 is 1, which leaves me with just 1x or x, and 38 divided by 19 is 2. Some of you might have known this value from here. 19 times 2 is 38, so x is equal to 2. Now let's work on our second example. 3 times 22.5. So 3 times 22.5 is equal to 67.5. X times 5 is 5 times x. We don't know what that value is. But we do know that the opposite of timesing 5 is to divide by 5. 5 divided by 5 is 1, so 1x, or just x. But if we divide this side by 5, we have to divide this side by 5. So 67.5 divided by 5 is 13.5. So x is equal to 13.5. This is the only number that you could put there to make those two ratios equal. So let's summarize what we've learned. There are two ways to solve for an unknown in a proportional relationship. Way 1 is to use common factors to reduce or common multiples to expand a given ratio to generate part of an unknown ratio. And way 2 is to use cross products to write an equation that can be used to solve for the unknown value.